Hello everyone, and welcome to the new episode of our series of solving LeetCode Daily challenges. And today we are going to solve a problem called longest subarray of 1's after deleting one element. And yeah, this problem is classified as a medium problem, which I agree with. And yeah, actually, the problem statement is almost obvious from the name of the problem, but let's get over the statement anyway. So we are given an array of integers. It's important that our numbers can be either 0 or 1, so it's mentioned in the constraint. And we want to find the size of the longest non-empty subarray containing only 1's. However, in our array of nums, we need to remove exactly one element. So even if we don't want to remove a value, we still have to do it. And this is obvious from the example number 3. So here we have the list of 3 numbers, and each of these numbers is equal to 1. However, we need to remove one number, and because of that, the answer is 2, and explanation says you must delete one element. Okay, and if we are going to look at the constraints, we will see that the length of the array is from 1 to 100,000, which basically tells us that our complexity should be either linear or like big O of n times logarithm of n or something like that, because yeah, quadratic complexity will be not enough to pass the time limits, and yeah. Okay, so let's move to the solution of this problem. So to solve this problem, you don't need to know any hard algorithms or data structures. However, it doesn't make it particularly easy. To solve this problem effectively, you need to think really hard before starting the implementation, because the planning is very important, and it's also true for like our day-to-day programming. You need to think a little bit about your code before you start implementing. By thinking about your solution, you will be able to make your code much easier to read, much easier to implement, and you will increase the probability that your code will work by avoiding a lot of corner cases. Okay, and I will show you what I mean when I will be showing the code. But for now, let me introduce to you the concept of segments for this specific problem. And by segment, I mean a longest possible subarray of consecutive items with the same value. So let's take a look at the example. So let's consider this example number 2 from our problem. And yeah, we have this array of nums, and it can be splitted in segments in this way. So at the beginning, we have a segment of zeros with the length 1. Then we have a segment of 1's with the length 3. Then once again, we have a segment of zeros with the length 1. Then we have a segment of 1's with the length 2. Then we have a segment of zeros with the length 1. And finally, we have a segment of 1's with the length 1. And yeah, this concept of segments will help our implementation dramatically. Important thing to notice about this array of segments: after we break up our array of nums, after we convert it to array of segments, our segments will have alternating values. So for example, if I'm looking at this segment, which is defined by 2 numbers, its value and its length, the previous segment and the next segment will all have the value of 0, because the value of this segment is equal to 1. And yeah, for example, if we are going to look at this segment, it has the value of 0, and the previous and the next segments will both have the value of 1, which is important for our solution. I will now show you my solution because it's much easier to explain the idea behind the solution by looking into the code. So let's do just that. Okay, so here is my solution. So first of all, suppose that we have already implemented a method that converts our array of numbers to the list of segments. And I will go through the details of that method later on. But for now, let's just assume that we have this method. And yeah, it's very important sometimes to abstract away from the complexity of the solution and just to think in a manner that, okay, this is already implemented. I will fill in the details a little bit later, but suppose I have this method that does this good thing for me. In this case, converting the list of nums to the list of segments. And yeah, I have also implemented a class segment, which is pretty easy class. It only contains two values: the actual value of the segment, which is either 0 or 1, and the length of the segment. We don't need to overwrite equals and hashcode in this case because we're not going to use this class in some complex scenarios with stats and maps. So we only have a constructor, we have getters, and we also have one method that increments the length of the segment, which will be used later. Okay, so now we have this list of segments. Suppose, let's consider some corner cases. Suppose that the segment size is equal to 1. This basically means that our array nums, either it consists of only zeros or only of ones. So suppose it consists only of zeros, then the length of the longest subarray of ones is, of course, 0. So we can just return 0 right away. Okay, now suppose that our array consists only of ones. Then we need to delete one number from that, and therefore the answer is the length of our segment minus 1. Okay, we have dealt with all of the corner cases. Now let's deal with the actual cases. So let's iterate through all of our segments. And suppose, yeah, if current segment is a segment of zeros, we will just skip it. And if it's a segment starting from 1, we want to know what is the longest subarray of 1's that we can get starting from this segment and possibly removing a 0. Because, yeah, in this case, we always want to remove 0. We never want to remove 1 because it will only make our answer less optimal. Okay, so suppose we have this method, longest 1 subarray starting from segment. I will show it momentarily, and it returns this the length of this longest subarray, and we will just update the result. And yeah, in the end, we will return the result. Let's take a look at this longest 1 subarray starting from segment. So we know that the segment with index I, or index in this case, is a segment of 1's, which is important. So first of all, let's take a look in this specific scenario. Suppose that our current segment is a segment of 1, then we have a segment of zeros, then we have a segment of 1's again. Okay, if the length of the segment of zeros in between those two segments of 1 is equal to 1, this means that we have two segments of 1's and 1 0 in between. We can remove this 0 and return the sum of the lengths of two segments of 1's. And this is what we're doing here. And if that's not the case, for example, if this segment is the last one, or if the length of the segment of zeros is bigger than 1, or something like that, then we can just return the length of the current segment. So yeah, this method is pretty easy. And yeah, that's basically the whole solution. I promised you that I will show you how did I implement this toList of segment method. So it's also pretty straightforward. We are creating a list of segments. We are creating a current segment with the value of the first element from nums and the length 1, and then we are iterating through this nums array. And if the current element in the nums array is the same as the previous element, we will just increment the length of the segment in the current segment. And if it's not, then first of all, we will add the current segment to the result, and then we will create a new segment with the value of current value in the array nums and the length of 1. And in the end, we will still have one segment that we haven't added to the segments array just yet, so we will add it and we will simply return the list of segments. Okay, so what is the complexity of this solution? This solution has linear complexity because, yeah, as you can see, we always have like one for cycle, and it iterates. Just at first it iterates by the array of nums, which has a length of, let's say, n, and then we iterate through array of segments, which has a length that is not bigger than n. So our complexity is big O of n. Okay, what lessons can we get from this problem? The main lesson, there are two lessons probably. The main one is, in the real coding interview, you need to think before you start implementing your solution. By that, you can save yourself a lot of time, a lot of nerves. Your implementation will be clearer, easier, and less error-prone. And the second lesson is, if you can, try to split your problem in the easier problems, like I did in my solution. So for example, yeah, I just created this subtask of converting our array of nums to the list of segments, and I assumed that I had it, and then I filled in the details. Even more than that, you can even talk to your interviewer like that, okay, suppose I have this method that does exactly that, and I will fill the details later, and maybe interviewer will tell you, okay, I trust you, you can do it by yourself, so there is no need to implement it, let's just assume that we have it. Okay guys, so thank you very much for your attention. That's it for today's problems. I hope you enjoyed it. Please like, subscribe to the channel. I will try to make these videos better and better every day, incrementally, just like in our programming, when we increment the quality of the code base on a daily basis. And that's what I'm going to do with this channel. So stay tuned, it will only get better. Thank you very much for your attention and have a nice day. Bye-bye.